All right, so in this problem number 35, the question A is 1 over x minus 1 equal 5 over 4. We just need to solve this equation. So we need to find the LCD. The LCD is going to be 4 times x minus 1 for the same reason that I previously said, to know how to define the LCD. I multiply by 4 times x minus 1 both sides. I end up to have 4 equal 5 times x minus 1. I add 5 both sides, and at the end of the day, I end up to have x equal 9 over 5. That's the only solution for the equation we were dealing with. Now we have an inequality. And the step number 1 is to pretend that you don't have an inequality, you have an equation. So when you try to solve this equation, you end up to have, at the end of the day, so you move by subtracting 5 over 4 both sides, you calculating the LCD in order to be able to subtract the 2 fractions. You have 2 fractions. That is your first fraction and that is your second fraction. And in order to subtract both fraction, you need to have the same denominator, and for that you need to calculate your LCD. So therefore you are able at the end to have 4 minus 5 times x minus 1 divided by 4 times x minus 1, and so finally the answer is going to be 9 minus 5x and 4 times x minus 1, which is 4x minus 4. So you can definitely look at the step number 2, which is going to be to try to find, and I'm going to write the step number 2 right here because step number 2 starts right here. So we are going to look at 9 minus 5x equals 0, so x equals 9 over 5. And the second one is going to be 4x minus 4 equals 0, knowing that in fact it cannot be equal to 0. So this is one of the reasons why we will use a bracket, parentheses. So step number 2 is right here. And so we end up to, after that, define a table where we are going to put x equal 1 and x equal 9 over 5. And we are going to calculate a value of f of x. For f of x equal 1 and f of x equal we are going to calculate value of x in each interval because we have defined 3 intervals, interval number 1, interval number 2, and interval number 3. When we are calculating these 3 intervals, we're just going to basically looking at, and we can substitute the value of x inside this interval, the value of x inside my inequality at the beginning, and when I substitute x equals 0 inside my inequality, I can clearly say that the inequality has been checked. When I substitute x equal 2 inside my inequality, it is also checked. So I can clearly define that the set of solution is going to be negative infinity 1 union 9 over 5 plus infinity. At least let's check that x equal 1.5 doesn't work. When x equal 1.5, I end up to have 1 over 1.5 minus 1, which is 1 over 1 over 0.5 and 1 over 0.5. So let me do that again. If I substitute 1 over by 1.5 minus 1, I end up to have 1 over 0.5, which is equal to 2. And that is way greater than 5 over 4. Okay? And so that means x equal, the interval corresponding to x equal 2 is not checked. It doesn't work. So this is why the solution was this. Now, if I look at the question number C, I am going to look at basically looking at f of x greater than 0, and I can clearly see that the only time you have f of x greater than 0 is going to be between 1 and 9 over 5. Okay? And when I put x equal 2 in this interval, only x equal 2 will end up to have 1 over x minus 1 greater than 5 over 4. Because when x equal 2, I end up to have 2 greater than 5 over 4, which is correct. Okay, so And it's not f of x equals y. I don't know why I put f of x equals 0, but the question C, it's all about checking that 1 over x minus 1 is greater than 5 over 4. So I'm going to use my interval that I calculated previously, x equal 2 between 1 and 9 over 5. And so I am going to substitute 2 inside my inequality and end up to realize that that's the only place where your inequality is true. All right, let's try to do another one. Let's try to do the problem number 39. So I'm going to do problem number 39. On the problem number 39, we have, for the A, we have 1 over x minus 2 square, 1 over x minus 2 square equals 0. And so we need to find a solution of that. The only way, when you have a fraction a divided by b, that your fraction is equal to 0 is to have your numerator equal to 0, because we know that the denominator cannot be equal to 0. In your case, the numerator equal 1. Okay, the numerator equal 1. Therefore, 1 cannot be equal to 0, and so the answer for the equation 1 over x minus 2 square equals 0, it's no solution. Now let's take a look at the B, which is 1 over x minus 2 square, 1 over x minus 2 square less than equal than 0. But again, it's going to be no solution. And why? Because x minus 2 square, it's something that is positive, okay? It is positive. So 1 over x minus 2 square will be positive. Therefore, there is no way you can find a solution when you are dealing with something less than 0. Finally, for C, we are dealing with 1 over x minus 2 square greater than 0. So we are just looking at 1 over x minus 2 square greater than 0, greater than equal than 0. So when I look at my step number 1, which is to pretend that we're having an equation, 1 over x minus 2 square equals 0. That means x minus, I know 1 cannot be equal to 0, but x minus 2 square is not supposed to be equal to 0, but if we pretend it's equal to 0 based on the process we have to follow, we end up to have x equal 2. So now we can have an number line where we are going to process and put the 2, and that defines two intervals, 1 and 2, and we can take a value of x equals 0 and a value of x equals 3. And if I substitute this value of x inside my inequality, what do I have? Well, 1 over 0 minus 2 square equal 1 over 4, and obviously that is greater than and equal than 0, so that's okay. And if I use x equals 3, I end up to have 1 over 3 minus 2 square, which is 1 over 1 square, and that is also okay. So I can clearly say that my interval solutions is going to be negative infinity 2, 2 plus infinity, but I must not take 2. Remember why? Because x minus 2 is on a denominator, and x equal 2 cannot be a value. X cannot be a value that x equal 2. 2 cannot be a value that x can be, because it will make my denominator equal to 0, and I know my denominator cannot be equal to 0, so I will end up to have a union. Okay guys, which problem do we have to do next? Alright, so in this problem number 59, that will be the last one, we have f of x equal 3 minus 2x divided by 1 plus x. 1 plus x. And we are basically, it's not f of x, yeah, it could be f of x, but we are just basically studying the inequality less than 0. So the first thing I want to do is pretend that 3 minus 2x equals 0, and then 1 plus x equals 0. because we have already 3 minus 2x over 1 plus x equals 0. So based on what we are supposed to do, we are supposed to look at these two equations. That the first one give us x equal 3 over 2, and the second one give us x equal negative 1. So when you are substituting x by negative 2, you are going to find that your function, your expression 3 minus 2x over 1 plus 2 is negative. So 3 minus 2 times negative 2 over 1 plus negative 2 is negative. So that is a yes. If I look for, and there is a pretty good chance that x equal 2 is also a yes. And yes, because when I substitute by x equal 2, I end up to figure it out that it's also less than 0. So it's also a yes. And obviously, when you are going to substitute x by 1.2, you will find something positive, and that is a no. Therefore, the interval notation is going to be negative infinity, negative 1, union 3 over 2 plus infinity. All right, guys, it's done for this chapter 5.3. So when you are substituting x by negative 2, you will end up to find that your inequality is true. Your initial inequality has been checked. There is a pretty good chance that x equal 2 will be also checked. And that's the case. You have something less than 0. So your initial inequality is checked. And so therefore, if you check the interval between negative 1 and 3 over 2, you will find it's not possible. And so the set of solution, interval notation, is going to be negative infinity, negative 1, union 3 over 2 plus infinity. All right, guys, so I wish you good luck. And if you have any questions, just let me know.